Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 288. Page number 288, please turn to it. Number 146 is what we're going to do. Let's take a look at it. In 146, they tell us. In 146, they tell us that average of 6 numbers. We have 6 numbers, and we are told that their average is 75. The question simply is, of these 6 numbers, how many of them are equal to each other? Before we do 6 of them, let's do something simpler. Let's pretend that the average is 7 and there are only 3. So the problem that reads now, the simpler version is, we are told that the average of 3 numbers is 7. How many of them are equal to each other out of those 3 numbers? First statement tells us that none of the 3 numbers are less than 7. So we know their average is 7. And the condition is that none of them can be less than 7. So can we have some numbers more than 7, like say maybe 9 and 8? Is it possible? If none can be less than 7, how can one number out of 3, if you have 3 numbers whose average is 7, listen carefully, if you have 3 numbers whose average is 7, and if I were to tell you that one of those 3 numbers is more than 7, what do you surmise from that? What do you gather from that? What do you infer from that? What do you deduce from that? If one of those 3 numbers is more than 7, then it must be true that another one of those 3 numbers must be less than 7. The average is 7, this guy is 2 more than 7. Because it's 2 more than 7, to compensate for the fact that this is 2 more than 7, this missing number better be 5. Otherwise their average would not be 7. We have to compensate for the fact that this is 2 more. Or if you want to look at the other way around, if this is 5 and if we are told that the average of 3 numbers is 7, this we are told is 7 and this is 5, because this is 2 less than the average, this better be 2 more than the average. In other words, if you have a whole bunch of numbers, and if we are told that their average is 75, the only way any of these numbers be more than 75 is if at least one number is less than 75. Because they have to compensate for each other, because their average is 75, which means if you were to multiply 75 times the number of numbers, that's their sum. And it cannot be. If we have 6 numbers and their average is 75, if we have 6 numbers and their average is 75, and if none of these 6 numbers is less than 75, if none of them we are told is less than 75, it must imply that none can be more than 75. None can be more than 75, because even if you had one number more than 75 in a whole bunch of numbers whose average happens to be 75, even if you had one number more than 75, then at least one number must be equally less than that number, however the other one is higher. Do you understand? If I have 3 numbers, let's say 4 numbers, and their average is 5. So here are the 4 numbers, 5, 9, and then 2 are missing. Now, here's what's going on. This guy, their average is 5. We are told that the average of these 4 numbers is 5. If the average of these 4 numbers is 5, this guy is 4 more than 5. This guy is 4 more than 5, which means these 2 numbers together must compensate for the fact that this guy is 4 more. He's too fat. He's 4 pounds heavier. Everybody's supposed to be on average 5 pounds. So we have to make sure that we take away, these 2 have to be at least 4 less than their fair share. So their fair share would have been 5, but they cannot be 5. Maybe this guy is 4, he's 1 less, in which case this guy has to be 3 less. He has to be 2. Or maybe this guy is 5, in which case this guy is 4 less and he is just 1. Do you understand? But if one number is more than the average in a group of numbers, it doesn't have to be 6. You don't have to have 6 numbers in a group. It could be 60 million. If one number is more than the average in a whole group of numbers, then at least one number must also be less than the average to compensate for the fact that one is higher. Here we are told that none of the 6 numbers are less than 75. If none of them are less than 75, then none can be more than 75. They must all be 75. They must all be 75. Voila. The question was, what was the question? How many are equal to each other? Well, 6 of them. The question was, how many of them are equal to each other? The answer is, all of them. Is that what they're asking? 144. Are all numbers... Well, that's what they're asking. Are all numbers equal to each other? I don't know why I rephrased the question. Maybe I'm reading the wrong one. If the average of the 6 numbers is 75, how many of the numbers are equal to each other? The answer is all of them. And we are able to give a definitive answer. All 6 of them are equal to each other. First statement does the job beautifully. And therefore, A, D, B, C, E. Because the first statement enables us to answer the question, how many of them are equal to each other? The answer is all of them. The answer cannot be B, C, or E. It will have to be either A or D. Let's see what they tell us in the second statement. In the second statement they tell us, that none of the 6 number is more than 75. Well, if none of them is more than 75, none can be less than 75. None can be less than 75. They must all be 75. What they're telling us in the second statement is the mirror image of what we just talked about. It's nothing different. Do you understand? It's just the converse of it. And therefore, second statement is also true. Second statement is also sufficient. The answer is D. Answer is D. Let's do the next one, shall we? 147. 147. Let's see what we have there. In 147 we are told, in 147, rather we are asked what was the total revenue from the sale of 400 tickets, some of which were sold at discount. Some were sold at discount. Now, before we begin to do the work, we have to ask yourself, pause for a second, for 3 or 4 seconds, and ask yourself what sort of information would you need in order for us to be able to answer the question, what is the total revenue? Well, total revenue typically is simply the quantity that is sold times the price. But here, the price is not uniform. Some are sold at full price, some are sold at discount price. So the very first thing we will have to know is the number or proportion of the tickets that are sold either at full price or at discount. Because if we know the one, we can figure out the other. Because altogether we are told 400 tickets are sold. So again, one more time, very first thing we're going to have to know is either the number or the proportion of the tickets that are sold either at full price or at discount. Similarly, we'll have to know either the full price. Actually, knowing simply the full price would not be enough. We will need to know the full price and the proportion by which it's been discounted, or actual amount of the discount price. So we need 3 pieces of information. Let's see what they give us. They were sold at a discount, which we are told is X%. In the first statement, they tell us that X equals 50. X equals 50. That simply tells us the sum were sold at half price. This simply tells us the sum were sold at half price. Oh, that's great. Some were sold at half price. But how many? How many were sold at half price? And the second question is, what is the half price? What is the price? Or what is the half price? If we know half a price, we can figure out the full price. We don't know the price, we don't know how many were sold at discount. This is not enough. The first statement is not enough. A, D, B, C, E. Because the first statement turned out not to be enough, answer cannot be A or D. It would have to be either B, C, or E. Let's look at second statement. In the second statement, they tell us that the full price is $20. That's great. Full price is $20. But that doesn't get us anywhere. We know the full price now, but we do not know how many were sold at discount and at what discount. How many were sold at discount and at what discount? We need to know that. We need to know how many were sold at discount so we can figure out how many were sold at full price, and we need to know what the discount was in order for us to figure out the total revenue, because in this case the total revenue is made up of two parts: the number of tickets that are sold at full price and the number of tickets that are sold at a discount, which is 400 minus whatever the full price tickets were sold. This is not enough. Second statement by itself does not do the job. Remember, we said we need three pieces of information. We needed the full price, we needed the rate of discount, and we needed to know either the number or proportion that are sold at a discount. It's not enough. And we can clearly see that when we put them together, we need three pieces of information. We're given only two. We're given the rate of discount and we're given the full price. But how many were sold at a discount and how many were sold at full price? Well, those are not two questions, those are one and the same, because if we know how many were sold at full price, we can figure out how many were sold at a discount, and vice versa. But we are not told that. We do not know how many were sold at a full price or at a discount, however you want to call it. Second statement, putting the two statements together, also does not do the job. 1 and 2 is still not sufficient. It's still not sufficient. The answer is E. The E's are very annoying. I find them very annoying because they don't give you enough information. They left you wanting. They left you needing more. Anyway, that's what it is. It's not enough. Do we have time to do one more? Let me take a quick look at what the next one is. This one was number 147, was it? No. Let's leave the next one for tomorrow. I'll see you tomorrow. Okay? Bye now.